That's a great idea.
All right, so recording is active. I'm going to share my screen. All right, can everybody see my presentation?
Affirmative.
Okay, so I'm going to be talking about ham mesh networks. So we'll start, let me see, we'll start at the beginning. So what is a high-speed data network? It's a connection or network of nodes that are hooked together. So if you think about that, it's kind of like the internet, right? So when you have the internet, you have a bunch of nodes out there. Some are servers, some are clients. They talk to each other over various networking mechanisms. Maybe you have cable internet, maybe you have what's a CenturyLink or a satellite or some other connection mechanism. So you have a way to connect to the internet, and you have a way to send information, data back and forth between different systems on that network. So it's very different from WindLink, which we had a presentation on a couple of months ago. We went to the West Valley Amateur Radio Club's meeting and learned about WindLink. The main differences are this is a high-speed network where the data is moving very rapidly and at high bandwidth, whereas WindLink is designed for very slow speed. If you recall, we were talking about WindLink operating over HF at 300 baud. When we're talking about the high-speed network, we're talking about operating at on the order of 140 megabits per second. So significantly higher speed than what you can push over HF. So that gives us capabilities that we can't do with WindLink. So we're talking about what people are doing for this high-speed broadband. So there's three major projects that are implementing what we call HSMM, or high-speed multimedia networking, on amateur radio. The first one was called Broadband HamNet. This was early days. The first time I played around with it was probably 6 or 7 years ago. It used the old blue Linksys routers. If you guys remember the old Linksys access point devices that had the two antennas that stuck up on either side, and they had like a blue box and the connection that your broadband connection would hook into. Basically, it was a specific firmware for those devices that allowed you to operate using some protocols that are more used for amateur radio. And we'll talk about some of the differences between the regular Wi-Fi and amateur radio in a bit. So the second one is a setup called HamWAN. Basically, this is a point-to-point data network. They often use the internet for a backbone. It's pretty complicated to set up. You have to know a lot about how networking works. If you've ever worked with things like AX25 or those types of packet radio systems, those are similar to this, but this would be running at a higher speed. But it's similar technologies to those types of packet radio setups. And then the popular one right now is called AREDN, the Amateur Radio Emergency Data Network. Can use amateur radio frequencies outside of the normal Wi-Fi range. It's relatively inexpensive to get going on it. The hardware's not that expensive. And it uses a mesh network, which we'll talk about a little bit more in detail as we move on. And there are, however, some politics associated with AREDN, and I'll talk about that a little bit as we move along a little bit further. So mainly we're going to concentrate on AREDN for this presentation. So what's the network? It's just like your home network. So at home, you've got a computer, you've got an access point, you've got maybe your cell phone, you've got your tablet, maybe it's hooked up to it. You're able to connect multiple devices. Maybe your printer is on there. So it's very similar to that. It provides data services. So we're talking about things like video, voice, text conferencing, file sharing, web pages or websites, distributed applications, that kind of thing. And it's mainly because we want to be able to share this kind of information without the infrastructure associated with the internet. What do we do if the internet goes down? What do we do if our cell phone network goes down? We don't panic. We get out our ham radios and we talk to each other, right? We do that because we know that when all else fails, amateur radio will work. And this is a setup that allows us to have these kinds of networking services even if the internet is down or completely unavailable. For example, if Comcast's main access point died for some reason, like it did night before last, and took my house off the network for a couple of hours. With AREDN, we would still be able to access services and communicate. It uses amateur frequency allocations, so we'll talk a little bit more specifically about that as we move on. But basically, it's taking advantage of our amateur radio licensing. So what can we do with it? We can do a lot of cool stuff with it. So get some examples here. So field day logging. This is a logging application called N1MM that allows you to, if say you set up a ham mesh network at field day, you would be able to do your logging online with able to share information with other people that are also there without having to have a connection to the real internet. So that's one example. You can do video, for example, webcams. And I want to show this page real quick. Let me see if I can share this. I have to share this separately. I want to share this page. So this is a setup called K7MSH that is run by the Utah Valley Amateur Radio Club. And this is a webcam. Can everybody see this web browser right now?
Yes.
Okay, so we've got a picture from Lake Mountain. This is live, or as of 5 minutes ago, looking northeast from the Lake Mountain repeater site. They've got another camera that's pointed southwest. There's a camera inside the hardware shack, so you can see what's going on inside the shack there where the radio equipment is in these racks. This is a view to the northwest from the radar, or from the radio site, the repeater site. And this is a view to the northeast, so you can see the antennas that are out here. I think this is some commercial antenna stuff over here, and then there's the amateur radio antennas as well. For whatever reason, this camera is not functioning, so some of these are not working correctly, but these are actual relatively live. This was at 6:35 was when this picture was taken. And there's no internet up there at the repeater site, but these are bridged through AREDN to somebody's router at their house, where they are putting it up on the regular internet so that you can access them from the internet. So that's an example of something that you can do. What we could do with something like that is, say we had a camera on a fire truck, for example. You would be able to throw that video back to the EOC so that the people at the EOC could see whatever the firefighters were seeing at whatever site they were at. So that would be an interesting application for that. Let's see, go back to my presentation. All right, here we go. So we can do phone, which is not radio phone as we call it, but this is actual telephone using voice over IP. So you can have a voice over IP phone server and connect desktop phones, handheld phones, even portable or wireless phones directly to it, and be talking over this voice over IP network. So you could have a phone at the EOC, you could have a phone in the truck, and the firefighter could pick that up, and not knowing anything about how the network works, he would be able to talk to somebody at the EOC just like he was talking on the telephone. You can do file transfers, so typically using FTP. A lot of people on the internet use SFTP, which is a secure file transfer protocol. We can't use that on the amateur radio frequencies because it uses encryption. But FTP is an older protocol that does not use any encryption, and it's perfectly legal to use that on the amateur frequencies. So you could have a file server that has forms or other documents that people might need to access, and they could use a client on their local PC to access those files directly over the file server. There's interactive chat where you're typing essentially back and forth with people, kind of like instant messaging. This is a chat client called Mesh Chat that is designed specifically for mesh networking, but you could use any chat system, IRC or whatever you want it to use, as long as you're not dependent on a commercial service for that. Email as well. You can run an email server on the mesh network, and then people can have an email client. So kind of like WinLink in that regard, where you can send messages back and forth, but you can do this over the mesh network. You could do screen mirroring, and this is a place, Steve, where, you know, if we had a mesh network up and running on the amateur frequencies, we could do this presentation over our radios without using the internet, using this kind of functionality. So, you know, it's something that is definitely possible when you've got a high bandwidth connection. You could also run a web server, and I don't have any pictures of web servers because it's hard to show a picture of server software, so I just threw up some icons of various browsers. But you could access web pages that are served over this network, so things like documentation or forms or anything like that that you needed to interact with, you could run those over this kind of high-speed network. There's also what they call a map server. So if you think about mapping, the way that maps are handled on like your Google Maps and whatnot, the maps are broken up into tiles, and you can put those rendered tiles on a server, and your clients can go access them directly from the server. That way they don't have to have a full copy of the entire map region. They can pull down just the specific parts of it that they want to access and do that over a map server. So basically anything that you can do over the internet, you could do over this high-speed network without having the internet involved at all. I want to go over some of the terminology that's used in this environment. So we have the concept of an access point, and I've thrown that word around a couple of times already in this presentation. An access point is essentially a bridge between wireless clients and a wired network. We call it an AP. So if you have a Wi-Fi router at home, that is an access point as well. It provides a connection to your wireless devices into your wired network. Ad hoc mode is a way of setting up a Wi-Fi network that is not using an access point. So each individual node is talking to the other nodes in the network. And we'll talk about that a little bit more in a minute too. The reason you might want to do this is if you don't have an access point, but you have, say you've got your phone and you've got your laptop and you want to connect the two together, you can connect those together in ad hoc mode and share files back and forth between your phone and your computer. Beacon is a packet of information that is transmitted by an access point periodically. It advertises the existence of the access point. Your networking devices will be listening for those beacons to decide what networks are available. If you've ever looked like on your computer, when you go to your list of Wi-Fi networks and you see half a dozen or more Wi-Fi networks out there, each one of those is showing up on your system because it is sending out a beacon message saying, hey, I'm here, I'm on this channel, this is my ID, and you know, you can connect to me if you know the password. In mesh networking with ham radio, the user's call sign is also broadcast. So that satisfies the ID requirements because it sends that out quite frequently. So you don't have to worry about IDing your network connection traffic. Channels are, think of those as like a breakdown of a particular frequency. The Wi-Fi standard has numerous channels. For example, On the 2.4 gigahertz Wi-Fi, there's 11 channels available. There's actually 15, but some of them are not allowed to be used in the United States. It says here there's 14, but I think there's 15. Channels have a bandwidth or width of the signal, and the greater the bandwidth, the greater the throughput. Ham mesh can use 5 megahertz, 10 megahertz, or 20 megahertz bandwidth on each of those connections. So depending on how much bandwidth you want to use, you can adjust that. Diversity is using multiple antennas to reduce interference and improve transmission and reception of signals. So if you notice when you buy your Wi-Fi router at the store, it has a couple of antennas on it. Some of them, the newer ones, have 3 antennas on them. And they do that because sometimes the position of the antenna matters a lot on getting the signal through. And so the having multiple antennas allows you to get a better signal through in various conditions. MIMO is also part of that. It's multiple input, multiple output. Basically, your network hardware, your radio hardware has to be able to support that using multiple transceivers and antenna to manage that. Nodes are devices that are on the network. So in your local network, your laptop, for example, would be a node. Your Wi-Fi access point would be a node. In the mesh network, any network device that is speaking on the air is a node. With mesh networking, nodes are self-discovering. So when you turn it on, it goes out and says, hey, I'm here. Who else is here? Figures out who else is there and hooks itself up into the network. Peer-to-peer, so nodes talk to each other directly. So the nodes will, if they can reach another node, they will talk directly to it. One thing that is fairly common to do in a business environment with a network is you would have multiple access points all using the same SSID, and I'll cover what an SSID is in a second, but that allows you to like move your computer from one part of the building to another part of the building and stay on the network, even though you're moving away from one particular access point and closer to another access point. So the ham mesh network supports that functionality as well. So the SSID is a service set identifier, and it's basically the name of the wireless network, and it's contained in the beacon. So if you look at your list of Wi-Fi networks and you see, like if you're here in my neighborhood, you'll see Peterson 3, Peterson 4. Those are both here at my house. The Peterson 3 is my 2.4 gigahertz network, and the Peterson 4 is my 5.8 gigahertz network. So you can connect to those if you know the password. And again, in ham mesh networking, you're not using a password because you're not doing any encryption. So what does this mesh idea mean? So if we look at our typical home network, we have the internet that is connected by a wire, typically to the Wi-Fi router, and you may have a desktop or a printer or something connected to that Wi-Fi router also by a cable, and then you have wireless connections to your laptop, maybe your phone, iPad, if you've got an Android tablet or ebook reader or something like that, Kindle Fire, or if you're using Roku or some smart TV type device, those would be connected typically through a wireless link back to the Wi-Fi router. The key factor is it's kind of a star network. You've got the Wi-Fi router here in the middle, and everything else is hanging off of that. So each thing only really talks to the Wi-Fi router. In a mesh network, you've got all of these different devices out there, and they can talk to each other. So each of these routers, like this one over on the far left, he's only got one connection into the network, but the guy that he's connected to has 2 connections that he can talk on. And so the advantage of this type of a setup is, let's say a particular router, like this one right in the middle, went away. There was a power failure, or the owner of it turned it off for some reason. If it was in a star type setup, then everybody else would be stuck. They wouldn't be able to talk to anybody. But because they're in a mesh setup like this, the system will automatically reroute traffic to find a path that works to get between the various nodes so that your data can get from one node to another. So that's basically the difference between your typical star network or Wi-Fi network that you have at home and this this mesh network. Um, the other difference is that when you turn one of these routers on or you bring a new router into this connection, it's going to look around and see who it can talk to and add itself in automatically. So if I brought another router and put it right here, it might be able to talk to this one and this one and this one, and it would figure that out dynamically, and then it would say, okay, I'm here, and all of you guys that need to talk to me, this is how you get to me. So it's very robust, it's very fault tolerant. This is a picture from Google Earth that shows where AREDN nodes are in the United States right now, and some in Canada. So you can see there's kind of a cluster here in Utah. There's a cluster down here in, looks like Phoenix. Los Angeles has a bunch. San Francisco has a bunch. There's a bunch up here in Oregon, Washington, the Seattle area. Out here on the East Coast, there's a ton. Down in Florida, there's a bunch. There's a bunch in Texas. And so you can see there's all these different isolated collections of nodes. Specifically in Utah, there's actually a couple on here that I didn't get on here that are up in the Cache Valley area. So this is really just the Wasatch Front. Although my slide says Utah, it's not just Utah. But there are nodes basically from Ogden down to Springville. And you'll see over here on the other side of Utah Lake, there are a couple of nodes on top of Lake Mountain. And so that's where those webcam views were coming from. When you look at this, you'll see some of these say 2, some of them say 5, some of them say 3. That's talking about the specific frequency band that they're using. So either the 2.4 gigahertz band, the 3.5 gigahertz band, or 3.4, or the 5.8 gigahertz band. And a lot of these, you can't really see it on this picture, but like if you were to expand this one here where it has the orange 5 at Lake Mountain, there's actually 4 2 gigahertz routers up there as well, and they're all kind of connected in together, so they're all talking to each other. But it only shows the 5.8 gigahertz one on this diagram. So you'll notice that right here in the middle of the valley where Murray is, there's not a whole lot going on. And that's something that I think our club could be instrumental in doing something about.
Yet.
So exactly, yet. You'll also notice that down here in Utah Valley, they've got one of these setups on top of Lake Mountain, which has a nice view of the entire valley. And so it's very easy for someone to point their radio at Lake Mountain and get on the mesh. Whereas here in Salt Lake, it would be really nice if we had one, say, at Farnsworth Peak, or somewhere up on the mountain somewhere. Or alternately, we could park one right on top of IMC's giant hospital in the middle of the valley that everybody can see. And that would be a terrific location for one as well. We obviously have to coordinate that with IMC, but that would certainly be something worth looking into.
Excuse me, what's the range on something like that?
So the range is up. It depends on your line of sight, right? And I'll hit that in just a second. But these are basically microwave links, so you can get up to 90 miles or more on a connection, depending on how high your antennas are and where what you're pointing at. Typically, the antennas that you're going to be using, you might get 10-15 miles out of. Inside your house, you might have it set up with a very local setup that only works inside your own property there. But yeah, you can get up to 90-mile range out of these things because it's microwave and line of sight. And being on the amateur band, we can actually use higher power than the commercial Wi-Fi stuff would be using.
So one question for you, Jan.
Yeah.
Are you going to get into antenna types? Because
I will, yeah. I have a slide with some antenna types coming up.
Okay, thanks.
So AREDN, I talked about that briefly as being the latest version of this this kind of setup. It's an open source project, so there's some software that you would get. You would load it onto a particular router access point device, and it would have the capability of joining into this network. AREDN specifically focused on emergency communications, but you can certainly use it for other types of communications, not just emergency communications. It's under very active development right now. There's several dozen people that are contributing code to this setup, and it has new releases periodically. It uses commercial wireless hardware. WISP is wireless ISP. So there are some types of hardware from a company called Ubiquiti, and I'm going to talk about specific ones in a minute. Or there's also MicroTik. They produce routers that can run this AREDN software. You can get signals up to 144 megabits per second on your IP network using 802.11n protocols. And all you need is a technician class license because it is up in the gigahertz range. So we have, as technicians, we have full privileges up in those ranges.
On the software side of the house there that you have on that slide, I'm assuming that a Pi device can run it.
Oh, well, normally the router itself will run it directly. It is Linux-based. It's using a system called OpenWRT. And so it's a specific wireless routing package that runs directly on the router hardware. You can run your local nodes and things on a Raspberry Pi just fine, but and theoretically you could put a Wi-Fi radio on your Pi and tie it into this kind of a network very easily. But what we're specifically talking about here is running on the routers themselves, not on the computing devices, the general purpose computing devices. So band-wise, we typically are using the 2.4 gigahertz band. And here's a kind of an interesting thing. So remember we were talking about the different channels that are available. So on the Wi-Fi channels, there's channels 1 through 11 that you can use in the United States. And these are the specific frequencies that they're using. These are in gigahertz, right? Because we are amateur operators, sorry, my neighbors are making lots of noise. Because we're amateur radio operators, we actually have access outside of the public commercial Wi-Fi band. And so they actually call these channels 0, -1, and -2. And they're actually frequencies that are not legal for consumer Wi-Fi devices to use. But because we are amateur radio operators, we can use those frequencies. They are within our band allocation. So the advantage of this is if you live in like an apartment complex or somewhere, you might open up your wireless connection thing and see 100 different access points out there. They're all sharing those same 11 channels. So having these extra channels that are outside of that range gives us essentially a lot less contention on those connections. On the 3.4 gigahertz, there is several channels that are available for use on that band. Typically, you'll see these 3.4 gigahertz setups used for backbone links, where you have some high-speed links between nodes that are on specific locations that have high coverage. So they'll have maybe a couple of these radios and then 3 or 4 of these 2.4 gigahertz radios. And then the 5.8 gigahertz band, again, you can see a lot of these channels are shared with the commercial or consumer Wi-Fi, but there are several channels out here that are accessible, usable by us as amateurs, but not to the consumers' devices. So there's no contention on those frequencies. We're able to use those. They are microwave bands, so they are line of sight. The rule of thumb for line of sight with microwave is you could either go 90 miles or through one tree. So you want to make sure that when you set your antennas up, you're not pointing through a tree to try to get to where you're trying to get to. So a lot of times people are going to set up an antenna on a tower where the tower gets it up above the trees in their local neighborhood. So that's a very common thing to do. Here's an example of a mesh network. So we have a fixed backbone node over here on the left. He's got kind of a wide angle antenna here that's running on 5 gigahertz or 2 gigahertz and one on 3 gigahertz. And then he's got some dish antennas that are running at 3 gigahertz that are pointing off to other fixed node locations. In this example, there's a hospital out here on the top right corner. And the idea is that, you know, you could have a node here at the hospital and be able to access information out on the network. This bottom right-hand one here, it says ham deployed to a shelter. That could be, you know, if you had to go into a place where they were bringing in people to shelter, for example. A lot of times they'll do that at a school. When we had the earthquake last month, we had Taylorsville High School identified as a shelter location for people who were displaced because of, you know, Magna residents who were displaced because of the earthquake, where their property was no longer safe to be in. They had to go there. Being able to set up a node like this, this could be a portable node, allow you to tie into the AREDN network and be able to communicate with people at the hospital if you needed supplies, people at the EOC or somewhere like that. So that's just an example of how you can do this kind of in an ad hoc fashion where, you know, this node doesn't have to be fixed in place. You can set it up wherever you happen to be. So we'll talk a little bit about the hardware that's involved. Oops, sorry, skipped ahead there. The radio hardware, typically people are using Ubiquiti M series Wi-Fi routers or wireless ISP routers or WISP routers. They'll use things like AirGrid, AirRouter, the Bullet. These ones on the bottom right are called Bullets. They have a connection for the antenna and a connection for an Ethernet on the other end. This one on the left is a I believe it's a Rocket. It has a couple of network connections, a couple of antenna connections, and this is designed to be mounted outside. It's weatherproof. You'd mount it like on the side of your house or something like that. This one on the top right is a MikroTik router. This is a device that has, think of it like a regular access point in your house. So it's got Wi-Fi built into it. It also has some Ethernet ports on it. A lot of people are suggesting set one of these up in your house, and then you can run a network connection from port 5 to a Ubiquiti router that's mounted outside, that's connected to your link that connects you into other nodes. So this would be running any of your services within your own house, whereas this one, or like at the EOC, for example, you could have something like that. And then the Ubiquiti would be used for that point-to-point link. Prices on these things range anywhere from $35 up to $200. I think the Power Beam is like $200. The AirGrid is like $35. The MikroTik routers are fairly cheap. I think they're available for around $45 to $50. It's not very expensive to get into it. Antenna-wise, I've got some examples of omnidirectional antennas. So omnidirectional antennas are basically, they can accept information from any direction. That's why they're called omnidirectional. So this would be just a simple pole type antenna, or fiberglass antenna, that you could mount on your house or somewhere like that. You could mount it on a pole or something. This one on the top right is another similar type of antenna. These ones down on the bottom are ones that you could attach directly to the back of, say, that MikroTik router. There would be a little port, an antenna port on the back of that, and you could connect one of these directly into that. Obviously, the small antenna is not going to be great for a 90-mile link, but you can certainly use it within your home. There are what they call sector antennas. So these types of antennas cover about 120-degree angle. So if you have 3 of them, like you see on the right-hand picture over here, you're basically getting full circular coverage around this antenna, but it's a lot more high-powered than a typical omnidirectional antenna. And in this environment, you'd actually have 3 nodes connected together, wired together, that are essentially operating independent links out the different directions. You can mount these sector antennas on a pole. You can point them at, an area that needs coverage. For example, if you were setting up at field day, you could set one of these up at the corner of the field day site and cover the entire field day site with that. Be very, very simple to set that up. Then the third type is a beam or directional antenna. So I have a Yagi right here in the middle, this kind of mesh wireframe antenna on the left and a dish antenna on the right. So you set these up for the longer links where you want a little extra power that's more focused for those long point-to-point hauls. So if we were to set one up, say on top of IMC, we could point one of these dish type antennas or Yagi type antennas at Lake Mountain and tie into the whole Utah Valley network that way. So fairly simple. These antennas range in prices from, $50 to several $100s, but some of these, like these wireframe ones, they're really not that expensive. I've got a couple of these Yagi ones that I picked up on eBay for I think $12 each. So they're certainly available out there. And that pretty much completes my presentation. And I'm really early on this. I thought this would go longer, but wanted to share some of the URLs that are important to look at here. The AREDNmesh.org, that is where you can go to actually download the software, get information about the specific software. There's a lot of good documentation on that site. I use this one called OEM.com. That had a really good primer on the mesh network. UT Mesh is the Utah Mesh Network site, and we can actually go there and take a look at that. If you looked at those webcam pictures, they were on that site. And then I also put together a playlist of YouTube videos that are specific to the high-speed multimeter HSMM type mesh networking. And so there's about a dozen little videos on there that give a really good view into that. And in fact, I'm going to go ahead and open that up and share that just so you can see what kinds of things are available there. Let's see this one. So this is the playlist that I've got. I put these in an order that you could follow through, so you're not like watching the most technical one first. But there's basically an introduction to AREDN, a mesh networking overview. And then there's this this blogger called Ham Radio 2.0, and he has several episodes about mesh networking. So his episode 47 is an introduction, and then episode 76 he actually talks about how to set one of these up. 78 he talks about how to connect these networks together, and 87 talks about running this in a remote location. So basically setting this up in a park. There's AREDN for preppers. I don't know if you guys are preppers or not. I'm technically not a prepper, but I like to be prepared anyway. My son's in-laws are big on the prepper side, and they go to all the prepper conferences and everything. I don't know if they know anything about this stuff, but if they don't, they're really missing out. There's a presentation here on VoIP, voice over IP, and using field telephones or voice over IP telephones. This guy has a little quick walkthrough of his home network that he's set up, and then there's a little Q&A session that the Ham Radio 2.0 guys put on. So those are pretty useful videos that you can look at. And again, I'll put this presentation on the website. I'll put all of these links on the website. So if you're wanting to go check some of these out, you can very easily do that. So at this point, I will open it up for questions.
First of all, I want to give you a round of applause. That was awesome. Thank you very much, Jan.
Well, I will accept your round of applause, even though we're not at Cub Scouts.
Yeah. One question I do have, do we have an example of what people are doing here in West Valley or Utah Valley Amateur Radio Club? It would be really interesting to see their hardware list and how they've put it together. So we don't have to learn this from scratch type of thing.
So on this Utah Mesh site, let me pull this back up again. Where did it go here? This one. So on this Utah Mesh site, they actually have several links on here. They talk about some of the different services that are used. One of the ones that they talk about is their K7 MSH camera system, and that's the one that I showed these pictures on, so you can get an idea of what the capabilities are there. There's also this KD7 VEA portable mesh node. So this guy's actually set up his Go box to include a mesh node, and he talks about everything that goes into it and how it's put together and how it's configured and everything. So nice little walk through here of how to set this up. So he's got it all in a little Go kit. It looks like he's got a Raspberry Pi in there, little screen on there, and it's all kind of tied together. But it's set up so that he can bridge this into an AREDN network from wherever he happens to be. All he needs is to point his directional antenna over at some fixed node, and he can be right on that network. Let's see. They have. Let's see, what else do they have on here? Some of these links, unfortunately, don't work. Some of them work okay. So this is an example, a list of Utah Mesh sites. And so here's a list of nodes that are actually on the Mesh network right now. So you can see what they've got. So this guy's got a nano station in Bluffdale. This guy's got a 60-degree sector antenna pointed east. He's in Layton. This one's out at the airport. It's got a 120-degree sector antenna pointed east. There's a couple on Antelope Island, Harriman. So you can.
So look, before you go away from there, look at the IP addresses. These are all non-routable IP addresses.
That's correct.
Which means this is a closed network.
It's a private network. That's right.
Private network. That is very interesting.
So now one thing that you can do is you can set up bridges. You can set up, if you've got if say you have a node at your house and you have connection to the internet at your house, you can always port forward things into the node, into the network, and access it that way. So it's certainly possible to expose some of these services on the public internet. But remember, the point of this is to be able to have access to these services without having the actual internet available. So even if the internet is down, you can still do this stuff over the air, right? Over your radio. So you can see, let's see, N1SC, that's Jeff McGrath, a friend of mine. He lives down there just off the point of the mountain behind Cabela's, and he's got a Rocket M with a 120-degree sector antenna pointed southwest. So he's on there. But yeah, essentially we would be able to tie directly into this setup and have our stuff appear on here just as well, and be able to put in whatever information, services, or things that we wanted to share on this network. Let's see. I didn't really need to do that.
So I'm trying to think of a practical application for all of the club members. I can see us putting, let's say we put a mesh node on top of the hospital, and that hospital, let's say we get two antennas, one pointing to Lake Mountain, the other one pointing to a node in North Salt Lake. Okay, so now we don't have a single point of failure. We're in the routable domain, right?
Right.
So me at my house, if I want to get onto that, do I try to point do I create another node in essence and point it to the hospital? Or, I mean, how can I be a client of the hospital node?
So what
Is
you
that
would
possible?
do is you'd set up the node at the hospital. So you'd have one node that is talking to Lake Mountain, for example, on that point-to-point type link. One that's talking to whatever you were looking at up in North Salt Lake, and then you would have one or two of those sector antennas, or three of those sector antennas that's kind of providing a general connection to anybody around, right? And so at home you would have maybe a Yagi antenna or one of those wire mesh directional antennas, and you would just point that at the hospital and tie into whichever node is pointing in your direction. And then once you can see that node, you're on the network and you can see everything on the network. So you would need some additional hardware, not just the two antennas on the hospital. You'd need some kind of sector antennas of some, or an omnidirectional antenna or something like that, that could cover the wider area.
So your own personal house would have to be set up almost like the hospital would be set up, because
you could do that, sure, yeah. So typically what you would do is you'd have like a Ubiquiti bullet or rocket or something like that is hooked up to a Yagi antenna and pointed at the hospital, and then that would be tied into one of those MikroTik routers that is in your house and providing full network services to anything you wanted to connect to it inside the house, whether that be a laptop or iPad or whatever, So you would access it through that. So that would be another node on the network, but it would be just specific to your location, your QTH there.
And one last question I have, and I don't want to tie up the airwaves with my questions, but okay, so now that the mesh network is set up in Murray, we have the fire stations connected to it. We're all looking at the IHC hospital and a few nodes around the Murray area that can access that. Now what do I do with it?
So let's say, for example, we had an emergency situation, right? Where, say, there was an earthquake or whatever, and we all went out and got deployed with our friendly neighborhood firefighters. So I'm sitting here on the fire truck with the Station 83 crew, and we're going around to various locations to check on things. I can call that in with voice, but that's subject to problems like what if you don't copy me very well, right? Or we've had demonstrations where you could see how many times did it take them to get that information about that particular hospital during the hurricane to get through to the people that needed to get through, right? With a data network like this, I could have my laptop on my lap in the fire truck and a Yagi antenna that I pointed back at the hospital, and now I'm on the network and I can send an email to the EOC saying, this is exactly what you need to know about this location, with numbers, text, whatever, pictures. I could send pictures through. I could send anything I wanted to over that connection. And I don't have to worry about it being translated by somebody who, can't hear me very well, or for whatever reason, maybe the voice bands are tied up with people checking on their moms and dads, or whatever. So it's another connection or network mechanism to be able to communicate.
Fantastic. And after we stop the recording, I will give a general announcement of next week's, which actually you touched on, but I don't want to put that in the recording.
Okay. Any other questions?
Yes, I have a question on, okay, I'm to the northwest of Murray, and so I'd probably need, instead of an omni, like most people in Murray, I'd need a directional to tie into that. Is that correct?
Well, so if we had a sector antenna on top of the hospital, for example, and you had a directional antenna like a Yagi or something, I think you would be able to tie in just fine over a distance of 20 or 30 miles.
Okay. So I'm only 6 away, so that
so you would be fine, right? So
yeah, right.
The
But I had another question along those lines. Let's say I deployed and I was somewhere. I was on a fire truck and we went out to the very southwest corner of Murray area. How would I know that I'd be able to connect in? Would it be would I be able to tell relatively easy if I was able to connect in? Because I wouldn't want to waste my time if it doesn't work. How
yeah,
would I do that?
as soon as you set your antenna up and pointed it at the hospital, your node would tell you if it's tied into the mesh or not. It would be very obvious to you if you're connected or not.
Oh, okay, that makes sense.
And just make sure you're on a ladder truck. So if you can't quite connect to it, just have them
Go up the ladder.
raise it up more.
I don't think anyone should use ladders over your age, Dan.
That's correct.
Or my
Including
age.
Or your age, exactly, yes.
you.
But yeah, so that's a good point, Ragnar, is that's something that we would want to do, is experiment with this and travel around to different places in the town or in the valley and test our equipment and see how well it works and make sure that we can actually connect from wherever we happen to be deployed to, so that we know that up front before the disaster strikes, right? So, it's just that's a readiness thing that we would want to do. We'd want to get out there and test it out and play with it and make sure we understand how it works and understand what we need to know to get our connections to come up.
Okay, it doesn't sound too expensive, but what basic equipment would I need, and what's the basic cost to where I could have a portable node available?
So you'd probably want to pick up one of those Ubiquity units for about $35 to $45.
Well, there's a listing right there. Portable mesh node that he's showing right now.
Yeah, so he's got a.
right.
Okay, there you go. So he's got a Air Gateway LR for $30, and then
I see that.
what else does he have in there? He's got a switch. He's got a Raspberry Pi. He's got a DC to DC converter.
I mean, the most expensive
LCD
stuff
display.
is the LCD display and his dual band
Yeah.
radio. Everything else is pretty inexpensive.
So
If I could expand on that on something a second, this is a mesh network, meaning that if Dan would set up a node, and since I'm so close to him, I could use him to get to the hospital and beyond.
exactly.
However, if his system goes down, then he is out of that mesh, and I need to find something else close by. So that's why it's important to have like almost an always on situation to have a good mesh.
Right, and so anybody who's got a tower in their backyard, like Dan, would be a good candidate for setting up one of these omni-directional antennas, so that anybody around that area could point to him. But again, here in the valley, because we are essentially flat in the middle of the valley, if we had a node up at Farnsworth Peak or somewhere like that, you could hit it from pretty much anywhere in the valley. So, you just have to make sure that you have a line of sight connection into where you're trying to get to. That's why I thought, the hospital would be an ideal location. It's right in the middle of the valley. It's pretty high. Pretty much everybody can see it no matter where you're at. So, that would be a good location to set something like this up.
Or on the tower that we almost had, right?
Right. Yeah, the tower that we're not allowed to use. So.
That's not dead yet. I need to this coming week. I'm writing me a note right now to get a hold of Joey, and we need to talk about stuff like this, because I'd also like to get a portable node in the mobile communications van that they haven't given to us yet.
Right. That would be very useful.
There is so many applications for this.
There really are. The sky is the limit on this, because it's a general purpose data network. So anything that you can put over a data network, you can do over this connection, right? So voice over IP, video cameras, you know, text, direct messaging, any of that kind of stuff. There are distributed applications that you could run over something like this. There's just all kinds of stuff you could do with this. You could have file servers and everything else. So.
And I will say that in all of the field days that I've been to with Utah Valley Amateur Radio Club, they've had a mesh network set up locally there where they've had VoIP phones at each of the stations, which sometimes there were some issues with it, but the concept was great. Everybody could communicate. You know, you'd pick up the phone, and they had it so that a particular phone would ring. You know, you didn't have to do anything. And, you know, again, just a number of different applications that I don't think I really haven't thought about. So this has been quite eye-opening.
Yeah, so I got at a field day setup, for example, you could have a VoIP phone sitting at the medical tent, and you could have a phone at each operating station. And if somebody had a problem, you know, they got a cut or whatever, they could pick up that phone and be talking to someone at the medical tent immediately without, you know, having to break into another conversation that might be going on or tie up a 2-meter radio or something like that. So
number 3, Band-Aid stat, station 2.
Exactly. You know, you could do something like that. And for our purposes, where we've talked about deploying out with the fire department, having a node on the fire truck or having a node that you can carry around in a backpack or in a suitcase or something like that, and be able to set it up wherever you happen to be. If you're at a park or if you're at you know, a school or something like that, you could set something like that very quickly and be on the network and able to communicate. And that's really what it's all about, is about communicating, right? That's why we do this whole ham radio thing, is so that we can communicate. And it's another communications mechanism that that is just, it's got some capabilities. I mean, it's not obviously not designed for long haul out of the local area. It's definitely a local area type of setup, or a metropolitan area type setup. But you know, the capabilities that it gives you are pretty darn useful. So.
And we sit in a very unique geographical location, Murray City. We're kind
Murray
of
is right in the middle. Yep.
We really could drive a lot of this stuff.
Oh yeah. Any other questions?
What I would like to do is I would like to maybe ask for volunteers who would like to be part of a mesh network committee to help you know, take this to the next level. How does that sound?
I'm going to stop recording. So
okay, good. Thanks.
We'll terminate this, and thanks everybody for your participation. And you know, I'll get this video up on the website so that people who weren't able to join us tonight can get a look at it. So I'm going to stop recording now.